You flip a light switch and the room floods with light, instantly. Or so it seems. But here's what nobody tells you. The universe has a speed limit, and every single thing you've ever experienced obeys it. Nothing happens instantly. Not light. Not information. Not even the signal from your brain to your hand. Reality is built from limits, and most of what we call mysterious in physics is just those limits wearing a disguise. Let's start with something simple. You're standing in a room. You flip the switch. The light appears. Your brain registers it as instant because the delay is so impossibly small that evolution never bothered to make you aware of it. But light doesn't teleport from the bulb to your eyes. It travels at a fixed speed, roughly 300 million meters every second. That means if your room is 3 meters across, the light takes 10 nanoseconds to reach you. You can't feel that, but it's real. Now here's the first thing that should make you pause. That speed limit isn't just for light, it's for everything. Information, energy, cause and effect. The universe has a maximum speed at which anything can influence anything else, and that speed is the speed of light in a vacuum. This isn't an engineering problem we'll solve with better technology. It's woven into the fabric of reality itself. Think about what that means. If the sun vanished right now, we wouldn't know for 8 minutes. Not because our instruments are slow, because the information that the sun is gone travels at light speed, and the sun is 8 light minutes away. For those 8 minutes, we'd still see it, still feel its warmth. The Earth would keep orbiting a ghost. Then, suddenly, darkness. And only then would Earth's orbit change, flung into a new trajectory. The gravitational influence of the sun's disappearance also travels at light speed. Cause and effect are bound by this limit. Here's the misconception people carry without realizing it. We think of space as a stage where things happen, and time as a separate clock ticking in the background. But that's not how reality works. Space and time are linked. They're part of the same structure. When you move through space, you're also moving through time, and the speed of light is the exchange rate between the two. This is what Einstein figured out, and it's why nothing with mass can reach light speed. You'd need infinite energy. The universe says no. Pause and predict what happens next. Imagine you're on a train moving at half the speed of light, and you shine a flashlight forward. How fast is that light moving relative to someone standing on the ground watching you pass? Your intuition probably says half the speed of light from the train plus the speed of light from the flashlight, so 1.5 times light speed total. But that's wrong. The person on the ground measures the light moving at exactly the speed of light, not faster. The universe doesn't add speeds the way you'd expect when you're near light speed. Instead, time itself dilates. Your clock on the train runs slower relative to the observer on the ground. Space contracts. The math bends so that light always moves at the same speed for everyone, no matter how fast they're moving. This isn't theory. We've tested it. GPS satellites orbit Earth at high speeds, and their clocks run slightly faster than clocks on the ground because they're in weaker gravity and moving relative to us. If engineers didn't account for relativity, your GPS would drift by kilometers every day. The system works because we've corrected for time dilation. Reality enforces its limits, and we've learned to navigate them. Now let's go smaller. You've probably heard that electrons orbit the nucleus of an atom like planets around a sun. That's a lie. A useful lie for beginners, but still wrong. Electrons don't orbit. They exist in probability clouds. You can't say where an electron is and how fast it's moving at the same time with perfect accuracy. This is the Heisenberg uncertainty principle, and it's not about measurement tools being clumsy. It's another fundamental limit. The universe doesn't allow certain pairs of information to be known simultaneously with infinite precision. Here's why that matters. If electrons did orbit like planets, they'd radiate energy and spiral into the nucleus in a fraction of a second. Atoms would collapse. Matter wouldn't exist. But because electrons are described by quantum mechanics, they settle into stable states. The uncertainty principle is what keeps you from falling apart. It's a limit that makes existence possible. People hear quantum mechanics and think it means anything goes, particles popping in and out of existence. spooky action at a distance, randomness. But quantum mechanics is one of the most precisely tested theories we have. It's built on limits. Energy comes in discrete packets called quanta. You can't have half a photon. Particles are described by wave functions that evolve according to strict rules. When we say a particle is in two places at once before measurement, we're not saying reality is fuzzy. We're saying the particle's state is a superposition, and the universe enforces probabilities until an interaction collapses that state into something definite. Let's talk about entanglement, because this is where people think the universe breaks its own rules. Two particles become entangled. You measure one, and instantly, the state of the other is determined, even if it's on the other side of the galaxy. Doesn't that violate the speed of light limit? No. Here's the key. You can't use entanglement to send information faster than light. When you measure your particle, you get a random result. The other particle's result is correlated. But you can't control what you measure. To confirm the correlation, you'd have to compare results using normal communication, which is limited by light speed. The universe allows the correlation but blocks the shortcut. The limit holds. This is a simplified explanation to make the core idea intuitive, but the mathematical structure is rigorous. Now step back. Notice how your intuition expects instant cause and effect. You push a door, it opens. You speak, someone hears. But dig into any of these events and you find delays. Sound is pressure waves in air, traveling at 340 meters per second. The signal from your brain to your muscles is an electrochemical cascade moving at speeds up to 120 meters per second. Even the force you apply to the door is mediated by electromagnetic fields between atoms, and those interactions propagate at, you guessed it, the speed of light. Here's a reality check that feels strange until you think it through. When you push a solid object, you're not touching it. The electrons in your hand repel the electrons in the object. It's electromagnetic repulsion all the way down. The sensation of solidity is a limit on how close atoms can get before their electron clouds push back. Touch is an illusion created by forces that refuse to let matter overlap. Electricity in a wire is another place people get confused. You flip a switch and a light across the room turns on. It feels instant, but the electrons themselves barely move. They drift through the wire at speeds of millimeters per second. What travels fast is the electric field, the wave of electromagnetic influence, which propagates near the speed of light. The electrons are like a row of dominoes. You don't need the first domino to physically travel to the. You just need the push to propagate, pause, and predict. If the universe has a speed limit, does that mean there's a smallest unit of time? A shortest possible moment? The answer is subtle. There's a timescale called Planck time, about 10 to the minus 43 seconds, below which our current theories break down. We don't know if time is continuous or discrete at that scale. Quantum mechanics and general relativity both work beautifully at larger scales, but they give contradictory answers when you zoom in that far. This is one of the open questions. The universe might have a smallest tick of the clock, or time might be smooth all the way down. We don't know yet, and admitting that is part of doing science honestly. Let's hit another misconception. People think relativity says everything is relative, that there's no objective truth. That's not what it says. What relativity actually says is that certain measurements, like time and space, depend on your reference frame. But the laws of physics are the same for everyone. The speed of light is the same for everyone. The structure of space-time, the four-dimensional fabric that blends space and time, is objective. Different observers slice it into space and time differently, but the underlying geometry is real. Here's a concrete example. Cosmic rays are high-energy particles from space, and when they hit Earth's atmosphere, they create particles called muons. Muons are unstable. They decay in about 2 microseconds. At the speeds they're moving, even close to light speed, they shouldn't make it from the upper atmosphere to the ground. They should decay mid-flight. But we detect them at the surface. Why? Because time dilation is real. From our perspective, the muon's clock is running slow, so it lasts longer. From the muon's perspective, the distance to the ground is contracted. so it has less far to travel. Both perspectives are valid. Both predict the same outcome. The muon reaches the ground. Reality is consistent, even though time and space are flexible. Fire is another place where everyday experience hides the limits underneath. You strike a match. It bursts into flame. What's actually happening? The heat from friction breaks chemical bonds in the match head, releasing energy. That energy breaks more bonds. The reaction cascades. Molecules of fuel react with oxygen in the air, releasing heat and light. The flame is a plasma, a state of matter where electrons are stripped from atoms. It glows because electrons are falling back into lower energy states and emitting photons. Every step in this process obeys conservation laws. Energy is conserved. Momentum is conserved. The temperature of the flame is limited by how much energy the chemical bonds can release. You can't make a match burn hotter than its fuel allows. Magnetism feels mysterious until you realize it's electricity in disguise. A moving electric charge creates a magnetic field. A changing magnetic field creates an electric field. They're two aspects of the same thing, the electromagnetic force. And here's the weird part. What looks like a purely magnetic force in one reference frame looks like a mix of electric and magnetic forces in another. Relativity doesn't just apply to space and time. It reshapes how we understand forces. Let's loop back to the core idea. Reality is built from limits, the speed of light, the uncertainty principle, the quantization of energy, conservation laws. These aren't arbitrary rules. They're the structure of the universe. And when you stop seeing them as frustrating barriers and start seeing them as the skeleton that holds everything together, physics stops feeling like a list of facts and starts feeling like a map of what's possible. Here's a final reality check. Particle accelerators smash protons together at 99.999% the speed of light. We've accelerated particles to within a hair's breadth of the ultimate limit. And every single time, the math of relativity holds. The particles gain mass as they speed up. Time dilates. The energy required to push them faster grows without bound. We've thrown everything we have at the speed limit, and it doesn't budge. Some people hear this and feel claustrophobic, like the universe is a cage. But think about it differently. These limits are what make reality stable enough for complexity to exist. If light speed were infinite, causality would break down. If the uncertainty principle didn't hold, atoms would collapse. If energy weren't quantized, chemistry wouldn't work. The limits aren't bugs, they're features. You started this video thinking a light switch worked instantly. Now you know better. The signal travels, the light propagates, your brain processes. Every step obeys the same fundamental constraints that govern stars, atoms, and the signal you're using to watch this right now. Nothing escapes the limits. Not you, not light, not information itself. The universe doesn't do instant, and that's exactly why it works.